Look, we're streaming. We're going. Yes. Do what? Oh yeah. I'm gonna teach you some coding. Okay, major grades. You're gonna have two major grades. Both of them are tentatively set for next Friday. The first one is a project with articles. Would y'all like me to show you that? Yes, see it on the screen. All the delightful details of that funness. Let me pull that up for you. So in Schoology, in the Unit 1 folder, there you go. So here is the first major grade. It's like a paper, but not really, because I don't really care about like your thesis and your introduction and your conclusion and all that stuff. I just need you to grammatically correctly answer some questions at an AP, AP level content. So I'm going to treat this like a free response type thing from AP. You'll have a free response for this class, but it'll look different than this, but it's the best practice I can give you, if that makes any sense. So what you're going to do, we're going to be talking about intellectual property probably on Monday, but you could look up like what it means to digitize. I assume you guys are quick enough to type in digitized. But there's 3 articles, and you're just going to answer all 5 questions about all 3 articles, and then you're going to find some article of whatever you want for your 4th article that you can answer those questions about. If you want to throw all those answers in a paragraph and sound like some cool, super, like blog author, then that's cool. If you want to just say, number 1, this was digitized. Number 2, I do expect complete sentences, correct grammar, all that jazz. Any questions about that? Does it seem unreasonable? Do that check, make sure. Or you guys are like, no, that's fine. Go for it. Okay, so that'll be one major grade. The other major grade will be a test over the content that we've been covering on bits, and we're going to do compression on Monday, and yeah, we'll probably do some intellectual property things too. So. Okay, let's move on. What's the next thing on the to-do list say? I will watch the video in a minute. Yeah. Look. Bam. Adjusted. Look at vocabulary words. Okay, I don't know if we've talked about these vocabulary words, but they show up on the test, and I want to make sure we're discussing them. So, if you want to write this down, go for it. You will need to know what these are. You ready to talk yet? You getting the ink in your pen, or you're waking your phone up or something? All right. All right, what's a bit? A 1 or a 0, okay? So that's like the student answer. So like 10 is made up of 2 bits. So I'm actually going to say like the unit of electricity to pass through a wire or be held in a cell to represent data. be a little bit more formal than that. We've drawn pictures and we talk about like you put those that information in those little cells. Yeah? So a bit is just one of those pieces of information. A byte, which I'm sure you've heard in the world. Does anybody know what a byte is? Fun trivia. 100 bits? It's not 100. It is only 8. So much smaller than you think, right? But when someone says, so for internet prices, they say that their speeds are in megabits per second. So it's, but then we always hold megabytes for our, so like on your files or whatever, it'd be like MBs, yeah. But a megabit, it would take 8 seconds to get a full megabyte through. And so they're able to say, we offer like, I don't know, if you offer 80 megabits per second, that's the same as offering 10 megabytes per second. But since they want you to pay bigger prices, they tell you how many bits they can get through for a second instead of how many bytes they can get. Like I just said? No, because if you are smart enough to look up the difference between a bit and a byte, it's good. It's like you saying, I ordered a hamburger and they delivered a hot dog, and they say, do you not know the difference? And you say, no, that was misleading. Like, they're different words. They tell you what they're providing, you sign up to buy it or you don't sign up to buy it, and that's it. That's it. So.
It's misleading, but not really.
But it's just because the words are similar, right? All right, abstraction. This is a good one. Have y'all ever heard of abstraction? You did it yesterday. What did you do yesterday? You went home early. Yeah, black and white images. Okay. So abstraction is taking a complex idea and breaking it down into smaller, simpler ideas. So you can't really say, like, hold this picture to a computer. What you can do is say, I'm going to tell which of your places to be ones and which of your places to be 0, and then I've broken this big idea down into a bunch of smaller pieces that you can actually understand. Okay. Analog versus digital. Have y'all heard this before? What? You've heard of an analog pencil sharpener? I do. Would it also be helpful for you to know where it is? Performance of locks? Clocks. Yeah. If I wanted to pass information on to not let Big Brother hear, then that would have been a good time. Watch too many spy movies. All right, analog. Yeah, clocks can be analog or digital. What else? You sure? Like your old phones? Those used to run off electricity, but they were still analog. Watches. Okay, so analog would be like would be defined as data emitted. 2 T's and transmitted? That looks weird. I'm in the computer science teaching, not English. Data is transmitted through a range of values. So, like, and then, okay, we'll do a definition of digital, and then we'll talk about the difference. This is data that is transmitted through a selection of values. And they're so different. So, let's see, what would be a good example? I'm going to give you like 3 solid examples. Good day, bad day. So if I walk up to someone and I say, how's your day? And they're like, it's pretty good. It's like, oh, so it's a good day? Sure, it's a good day. Awesome. That would be like a digital, because I gave them options, they picked it. So if I walk up to someone and I say, how's your day going? And they tell me, they're like, well, I woke up early, that was nice, I got to exercise a little bit, but then I burnt my toast and that stunk. And then, and then they have like a full day of stuff, right? And so you go, so I'm guessing like from, good to bad, you're like more on the good side, you kind of have a feel about where they are, right? That's analog, because it's in the range of the values. It's not just like good or bad. I know about where you are. Pain. Pain's another one, right? Like, there is a distinct difference between a bee sting and a slap on the wrist or something, right? Like, those feel different. But if you were to say, like, does it hurt? Like, I guess so, more than not, right? But you could ask the same question to someone who like just broke their leg. Like, does that hurt? And they're like, yeah. Oh, so it's like a bee sting. No, it is not. It is not anything like a bee sting. This is terrible pain. Yes? So the difference in analog and digital is like in analog you have this full spread of ideas instead of being on or off, yes or no. And we'll talk about phones because that's a fun one. So your phones used to, your phones were transmitted over an electrical signal, and it was a wave. So it wasn't just like yes or no values. But now, what they do is they turn in all your information into bits and they send that out. But in order for them to do that much more effectively, they cut off the high highs and the low lows of your voice. And so now the information that's transmitted, phones are so much worse quality than they used to be. So you could like pretend to be your siblings or your parents pretty easily, whereas like 30 years ago you couldn't do that because the information that was transmitted was much more pure because it was an analog signal. It was stupid expensive, and there were lots of other downsides. I'm not saying life was better back then. I'm just saying they've changed how they transmit sound because of analog versus digital. Do y'all have a pretty good idea what that is now?
So what does this have to do with clock? Why do we call it analog?
Oh, okay. So when I watch a clock that's analog, I can see the hand move, the second hand. And it's not like a magic trick when it becomes 10:16 to 10:17. I don't go, ta-da, surprise! Like, I see it coming because I see the second hand move around, right? But with digital, it's either 10:16 or it's 10:17. I have a selection of values, but that clock gives me a range because it just is moving. Do y'all see why they call it that? Make sense? Yep. Okay. So yeah, there's some vocabulary words. We'll cover a few more later. Let's talk about, well, I don't know, let's see what the old agenda says. ASCII. Have y'all heard of ASCII before? Yeah, somewhere. Yeah. Let's talk about it. Oh, huh. Yeah. Let's see real quick. 2 to the 8th. I should know this. It's 256. Cool. So a byte is 256. Right? Would it help you if I zoomed in a little bit? On this side. On this one. So a byte is 256. And so all your information that you put in like a word processor or whatever, and even from your keyboard, those are just transmitted as numbers, right? So like a space, where's space? There's space, number 32. 32 is a space. 0 is not 0, it's actually number 48. Right? So I can like send coded messages. So if I said like 67, 97, 116, what word did I just say? 67, 97, 116, cat, and I capitalized it. Right? And so like your essays that you write for English in a word processor, held like this. Cool, right? And if you don't think it's cool, keep your mouth shut. But 2 to the 8 is 256 possibilities, and that's a byte. So what on earth do they do with the other ones? Whee! You know, there's like multiplication or other symbols, all those extra stuff you see in Word. That's what they're holding. Okay. Are we good on ASCII? I was supposed to spend a whole day on that, but I thought that sounds good. So there you go. There's your ASCII information. All right. We can watch the video. And if you're on the screen over there, I would not recommend watching it on that because it gets slow. So this is in lesson 8. We just did lesson 7, right? Yeah, this is lesson 8 of RG or of Unit 1. So there you go. You want me to turn the lights off as we watch? Does it help? Yeah. All right. Hang on. Can you turn it up?
Notice when you change the data by typing or using sliders, the binary data changes and the image canvas reflects the changes. There's another piece of metadata here called bits per pixel, which will allow us to make more you mix a lot of paint together, the color gets darker and darker. When you mix a lot of whites together, the color gets brighter and brighter. It can take some getting used to, but you'll get the hang of it. With only 3 bits, we know that I can only combine them 8 different ways. So with 3 bits, only 8 colors are possible. Now you keep going and finish the remaining 2 colors.
Okay, so you're going to be looking at the color imaging section, and then, okay, let's go back. So we just watched the video for section 1, maybe? I don't know. And then, and so they introduced the idea of having multiple numbers to turn things on and off, and they'll walk you through that. What I want you to do, like what you're turning in, is the gradient at the end. So, do y'all know what a gradient is? What's a gradient? Do what? Yeah, it's like this cool blending, and you can't really tell where one starts and one stops. And so I want it to be 8 by 3, and I want you to use at least 3 bits per color. So it'll be a setting of 9. So you got 24 little boxes to kind of make a blend and mix of colors. So, any questions? See, and that's the 8 by 3 and 9. And so this is one full row of black. Just copy and paste it. Get working on, making a blend. Any concerns before I release you? Nope. Have fun, be smart, ask questions. Bye. Only they told you to do that in life, right? Hey, stream. Listen, students. If you have things to ask, let me know.